welcome to another college math video. In this video, we're going to take a look at odds, one unique aspect of probability. Our objectives for the video: look at vocab and concepts related to odds, and then solve applications involving odds. Odds is definitely something that you, I would assume, have heard of on TV and the news and the radio, commercials. I know I see it referenced quite a bit. It's an area that people often don't have a good understanding on, and so often the media makes mistakes with it, which is kind of funny. At the end of the video, I'll show you one big mistake that was made from a pretty big company. So let's take a look at actually how to find odds and then what exactly it means. So there's two ways that we can look at odds: odds against and odds in favor, and each case conveys the exact same information. It's just a matter of what are you presenting first. Odds against is presenting the failure first, and odds in favor is presenting the success first of whatever our event might be. So the definition of odds against is a ratio. A ratio is comparing two things to each other, so it's a ratio of the probability that the event will fail to occur So probability the event will fail to occur, to the probability that the event will occur. Ratio of two things. Yep, there it is. Probability the event will fail to occur. I'll use red to signify failure, to the probability that the event will occur. So the definition is just kind of a clunky way of summarizing what this little formula says: odds against, probability of failure over probability of success. This is how we'll start things out. There'll be a little work in simplifying along the way. In every case, our denominators will be the same, because remember we saw probabilities in the last video, and each probability, for the most part, unless it was 0 or 1, has a denominator. So there'll be a probability on top and on bottom. Each one will have the same denominator. Denominators will wipe out, and we'll just deal with numerators. So that's what will happen in this simplify step. And then ultimately, our presentation of odds looks like this. You've heard people say the odds of blah, blah, blah happening are this to this. This is what it looks like. 7 to 5, 8 to 1, something like that. So you'll see what the simplifying looks like, but this is how it will show up. The failure number will be the first number because it's on top in odds against, and the success number will be the second number. If it's odds against, then we want failure to success, and this will be a cycle that we're seeing. For every this many failures, this many success. That's what odds against looks like. Okay, odds in favor is the exact flip of it. So the definition looks identical, except the order of the two is reversed. So it is still a ratio of the probability that the event will occur to the probability that the event will fail to occur. Okay, so again, the two things we're seeing are failure and success. In this case, failure is listed second, and success is listed first. The same two pieces of information, they're just flipped. Odds in favor puts success first, and so the steps will be exactly the same. There'll be a little simplifying, which can be done by hand or in the calculator, and then your final presentation of odds always looks like this: number, colon, number. You'll get those numbers from the individual components. And again, failure this time is the second number. It's on the bottom, so it's second. And success on top, so it'll be the first number. I feel like it looks a lot more complex here than it actually is, but these are the formal definitions and the formal process of what it looks like. So let's go ahead and look at an example of these. All right, so let's say we're spinning a dreidel. The options are nun, gimel, hey, and shin. I've seen the spellings a few different ways in a few different places, so I'm just going with what I've seen. These are what the options look like if you're interested. Now, the big questions are find the odds against spinning a gimel. In the last section, we looked at finding probabilities, but here the questions are about odds. So this is going to be the question we care about, the odds against spinning a gimel. Odds against means that we have probability of failure for the event, which is spinning a gimel, over probability of success. So while we don't necessarily care about each of those individual probabilities, in order to find odds, we need those probabilities. So let's find the odds of the probability of spinning a gimel and not spinning a gimel. So spinning a gimel, how many options are there? We have 1, 2, 3, 4. Our denominator is the best place to start when coming up with a probability. And then of those 4, how many meet our criteria of being a gimel? Only 1 of the 4. So 1 out of 4 times we can expect to spin a gimel. Of course, in the real world, it may not work out that way, but that's what you could expect. Okay, then what does the failure to spin a gimel look like? How many options are there for the denominator? Still 4. Of those 4, how many are failure to spin a gimel? 1, 2, 3. The others? And it'll always work out this way, that you have the same denominator in the fractions, because it's always the same event. It's just some of them are it happening and the rest are it not happening. And you can also always find that the numerators add up to give you the denominator. The event either happens or it doesn't, so you account for all pieces. Sometimes it does, and sometimes it doesn't. So those are the probabilities. Let's plug them into the formula. Probability of failure is 3 over 4. Probability of success is 1 over 4. And here's the simplifying that happens. As I mentioned, every single time you will have the same denominator on top and bottom. And so those denominators will always cancel out. You can find information on how the algebra works on that. I'm not too concerned with that since we don't see it too much and they're always exactly the same. You could also type the entire thing in your calculator, that's fine. But it'll always work out that those 2 denominators cancel and then leave you with numerators. Now, if these numerators could simplify more, then you should do that. This could simplify to the whole number 3, but we know that what we're looking for ultimately as an answer is number colon number. So it's nicer to have a fraction still, because this is not any fraction that has any real meaning for us. It's just a means of getting to 3 to 1. Our failure number first, success number second. So the odds against spinning a gimel are 3 to 1. And what that exactly means, this is how you read it, 3 to 1. It means for every 3 failures, there will be 1 success of the event, which in this case is spinning a gimel. So this is odds against, failure first, 3 failures, 1 success. It's a cycle, 3 failures, 1 success, 3 failures, 1 success. That's what you can imagine would happen if this experiment, spinning the dreidel, was done over and over and over. It's a cycle of 4, 3 failure, 1 success, which is the denominator we had, and that's to be expected. Okay, the second question is finding the odds in favor of spinning a gimel. Same event. This case, we just want odds in favor. Odds in favor is probability of success. Actually, I'm going to write it below. Probability of success over probability of failure. We already found those individual probabilities. Success of the event is 1 over 4. Failure of the event is 3 over 4. We simplify. The denominators cancel. They're always the same. They will always cancel out. We have 1 over 3. There's nothing left to simplify, so we put our final presentation of odds. Top number first, bottom number second, 1 to 3. This says, for every 1 success of spinning a Gimel, there will be 3 failures of spinning a Gimel. You might be noticing that the two numbers are the same, just reversed. And so you're wondering, is that the case every time? And it is. It's just a matter of both numbers say the same information. It's just a matter of which are you presenting first. Odds against gives you failure to success. Odds in favor gives you success to failure. So if you find one and you're asked to find both, just flip it. You don't even have to go through this process again. You can just flip it. It's just a matter of choice on why someone would pick odds against or odds in favor as their presentation, but you will be asked specifically for one or the other. Or if it's both, then you know you can find one and flip it to have the other one. Okay, let's see another example. All right, so there's a link up top here. A little difficult to see on the video, but it's in the PowerPoint, so you can go to that if you want to. We have some information on popular German foods at Oktoberfest chosen to eat. A little difficult to see the colors, I apologize. I'll fill them in. The items are Steckrellfisch, which is grilled fish on a stick, Haxen, which is pork knuckle, Wurstel, which is sausages, Blackraut, which is red cabbage, and Reiberdatschki, which is a potato pancake. So the percentages for each, the Steckrellfisch has 20%. I'll just write them above the word. The Haxen has 20%, chosen 20% of the time. The Wurstel is chosen 25% of the time. The Blackraut is chosen 5% of the time. And the Reiberdatschki is chosen 30% of the time. So these are the items, and these percentages are made up so that we can manipulate them, but these items are real. That could be at Oktoberfest. All right, so the question, find the odds in favor and against the food chosen being Wurstel. So the event is Wurstel. We want odds in favor and against. So let's start with odds in favor. Odds in favor is probability of success over probability of failure. Success is Wurstel. So what's the probability that Wurstel is chosen? Well, the percentage of the time it's chosen is 25%. So how do we make that a fraction? 25% means 25 out of 100. 25 out of 100, simplify, use your calculator, do it by hand, is 1 over 4. So the probability that Wurstel is chosen is 1 over 4. The probability that Wurstel is not chosen would be the remaining portion. You could add up the other percentages, or we know if it's out of 100, which percentages are, then it's the rest, 75 out of 100, or alternatively, you can use the 1/4 to get the matching fraction of 3/4. So the probability that Wurstel is chosen, the success, is 1 over 4, and the probability of failure that it's not chosen is 3 over 4. We have the numbers. Now we go through the process of simplifying. The denominators cancel. We're left with 1 over 3. We write as odds 1 to 3. For every 1 time it is chosen, there will be 3 times that it's not chosen. That's what that says. Okay, that's odds in favor. We also want odds against. And remember, if you find odds in one direction, in favor, for example, you can find the other one by just flipping it. So odds against, very simply, without having to go through any of the process, would be 3 to 1. For every 3 times it's not chosen, there's 1 time that Wurstel will be chosen. Let's do another example in this chart. Find the odds in favor and against, odds against Blackraut being the chosen food. So let's start with odds in favor. You could start with whichever one you want to. Odds in favor is success, probability of success over probability of failure. The event is Blackraut being chosen. So what's the probability that Blackraut is chosen? Blackraut is chosen 5% of the time. So 5 out of 100, because it's a percent. 5 out of 100 simplifies to 1 over 20. By hand in the calculator, it doesn't matter. You just need to get there. Which means the probability that black route is not chosen, or the failure number, is whatever's left over here out of 100 or out of 20 times. Once it is chosen, the remaining piece is 19. So 19 times it's not chosen. We fill them in. Probability of success, that it is chosen, 1 over 20. That it's not chosen, 19 over 20. 20s cancel. We have 1 over 19, which as odds says 1 to 19. Odds in favor, 1 to 19. For every 1 time it is chosen, there'll be 19 times it's not chosen. For a cycle of 20, which is the denominator that we had, we will soon be going backwards, starting with odds and going back to probabilities. So it's helpful to understand that 1 to 19 is a cycle of 20, denominator 20. Okay, we also need odds against black route being chosen. So against, you can use all this information to go through the process again, or you can just flip it. 19 to 1. Same information, just different presentation. Odds against says for every 19 times it's not chosen, there'll be 1 time it is chosen. Odds in favor says for every 1 time it is chosen, 19 times it's not chosen. It's just a matter of where you're putting the attention first. Okay. One more example before our practice problems, and this is the going backwards problem. The odds against your train from Paris to London being late are 7 to 2. What's the probability of your train being late? So we have odds against, which means probability of failure over probability of success. What's the event in this case? The event is the train being late. So we want the probability of the train being late. Even though late is a negative thing, it's success of the event. So ultimately what we're looking for is this fraction. Now, imagine, typically we filled in this way, but let's go ahead and fill in backwards. What we know is 7 to 2. Go backwards. What do we usually have in the step before? We have this thing as a fraction, but this fraction isn't helpful. This is final answer. What do we have before that? Before that, we've got the individual probabilities, where each of these numbers is the numerator, and the only thing we're missing that we've canceled out to go this route is the denominator. So how do we figure out what the denominator is? Well, remember that odds is a cycle. For every 7 times it does not happen, there will be 2 times that it does happen. That's a cycle of 9 times, so that's your denominator. 7 out of 9 times it won't happen, 2 out of 9 times it will happen, the event being your train being late. So our final answer is 2 over 9. We want the probability of train being late, the event, train being late. Again, I know being late sounds like failure, but it's the event. The event happening, train being late, 2 out of 9. The event not happening, 7 out of 9. 2 out of 9. It's your call. You'll have to, analyze which one it's asking for. But this process is always the same. Here's what you're starting with. If you're looking for probability from odds, you build it back to a fraction, you build it back to the fraction over fraction, and the only thing you'll ever be missing is the denominator. You can add up those 2 numerators to get the denominator, and then choose which one is your answer. Or sometimes it's both. Sometimes they ask for both. All right, so let's go to practice problems. We have 2 sets. The first one is like what we just did. So let's go ahead, pause the video, try this one out, and see if we're on the same page. Okay, the odds in favor of winning a car are 1 to 34,999. Odds in favor means probability of success over probability of failure. And what's the event? Winning a car. So success of winning a car is on top, failure of winning a car is on bottom. The odds are 1 to 34,999. The question, what's the probability of winning a car and probability of not winning a car? So we actually want both. Probability of winning is success, and probability of not winning is the failure fraction. So go backwards through the process. 1 over the 34,999 that we have, and then go back to the individual probabilities, which are those same numerators that we have. The only thing we're missing is denominator. For every 1 winner, 34,999 losers, a cycle of 35,000 people. So the probability of winning is 1 over 35,000, and the probability of not winning, 34,999 over 35,000. All of this information is the same. It's just conveyed in different ways. If you're looking for probability, it looks like this. If you're looking for odds, it looks like this. But both sets of information convey the same idea. All right, let's take a look at the other practice problems. Go ahead, pause the video, go through these. Remember, after we go through these 4, I'm going to show you an example of a movie making a mistake with odds. Okay, again, there's a link at the top of this page. It should show up better on your printed slides if you're interested in going to the link. This is information on the number of international visitors in millions a year for a set of countries. So let's say 1 is chosen randomly from the list. Find the probabilities or odds. I've put both in this section. Even though this section is all about odds, it's still important that you understand the distinction between probability and odds. So the first 2 questions are just probability. Let's go red. Find the probability that the visitors are more than 13.0 million. Well, for probability, we first need a denominator. So how many different options do we have? From the chart, we can count. Looks like we have 10. Of those 10, how many meet the criteria of having visitors greater than 13.0 million? It looks like they're in order, so I'm going to mark on here. All of these are visitors 13.0 and up. So we'll count. There are 1, 2, 3, 4, 5, 6, 7 that meet that criteria. So 7 out of the 10 have visitors more than 13.0 million. There's nothing we can simplify, so that's it. Okay, second question, find the probability that the location name has a B in it. Remember, 1 is being chosen randomly from this list. So again, we have 10 choices. Of those 10, how many meet this criteria of having a B? Let's go ahead and mark. Hong Kong, China, no. London, England, no. Singapore, no. Bangkok, Thailand, yes. Paris, France, no. Macau, no. Shenzhen, China, no. New York, USA, no. Istanbul, Turkey, yes. Kuala Lumpur, Malaysia, no. So of the 10, how many meet the criteria? There are 2 of the 10. Simplify by hand or in the calculator. We get 1 over 5. Remember, this simplifying can be done in the calculator by typing in 2 divided by 10, hitting enter, and then hitting the math key, which is typically at the top left-hand corner of your calculator. If you're on a TI 83 or 84, up here, top left, math. The first option you see when you hit the math button is an arrow and then FRAC. That means change to fraction, and it'll always give you simplified. So hit enter again, and you should see 1/5 or 1 over 5. Okay. The third question here is find the odds in favor of the location having the letter E in it. This is odds in favor. Odds in favor is probability of success over probability of failure of our event. And the event is that it has the letter E in it. So let's say probability of E. So let's go ahead and mark which ones have an E in it. Hong Kong, China, no. London, England, yes. Singapore, yes. Bangkok, Thailand, no. Paris, France, yes. Macau, no. Shenzhen, China, yes. New York, yes. Istanbul, Turkey, yes. Kuala Lumpur, Malaysia, no. So the probability that it has an E, 1, 2, 3, 4, 5, 6 out of 10. And probability that it does not have an E would be the rest, the other 4 out of 10. I didn't simplify yet. It's your call. Usually I simplify first. It just didn't happen. These are relatively small numbers. Continue on. Remember, the denominators are the same, so they will always cancel out, leaving you with 6 over 4. And then we can simplify that to 3 over 2. But the question was odds, so your presentation should be 3 to 2. For every 3 times it does have the letter E in it, there'll be 2 times that it doesn't, for a cycle of 5 as a condensed version. The 5 cycle would repeat to give you the 10, but the 3 to 2 is the cleanest way to say it. Just like we wouldn't say 75 out of 100 times this thing occurs, we would clean that up to 3 over 4. The same goes for odds. We always want the most condensed, cleanest version of the information. All right, and then one more question. Yeah, let's go blue. Find the odds against the number of visitors being less than 16 million. So odds against is probability of failure to probability of success. Yeah, that looks all right. For me, it's easier to get the success fraction first, so I'm going to start there, even though it's on the bottom. It doesn't really matter. The event is less than 16 million visitors. So on the chart, it looks like starting here and going down. So out of the 10, how many meet this criteria of less than 16 million visitors? 1, 2, 3, 4, 5, 6. Which means failure are the rest, the 4 out of 10. Again, denominators cancel. I'll keep going in red. We're left with 4 over 6, which simplifies to 2 over 3. And our presentation of odds says 2 to 3. For every 2 times there is not less than 16 million visitors, there'll be 3 times that there is less than 16 million visitors in the one city chosen randomly from the list. Important distinction to understand between the difference between probability and odds. What's the probability? You're most likely presenting a fraction. The only time it's not a fraction is if it was one of those unique scenarios where the thing can't occur, so it's 0, or the thing must occur, so it's 1. If the question is odds, your final answer should say number colon number. So keep that in mind. Okay, the last thing is to give you one of the examples of odds being messed up in a movie. So maybe you have seen this movie, maybe not, Zootopia. Towards the end of the movie, in a pivotal scene, one of the main characters makes this claim. She says, 90% of the population is prey. And the very next sentence out of her mouth is about odds. She says, prey outnumber predators. And I don't know how I knew this, or if I just thought it might happen and for some reason it did, but I knew they were going to say it wrong. Before I fill in the number, 90% of the population is prey means 90 out of 100 is prey. So 9 out of 10 are prey. That means the rest are not. So not prey would be 1 out of 10. So if we were going to say odds, it would be 9 over 10 over 1 over 10, which would be 9 to 1. But she says prey outnumber predators 10 to 1, which is not the same. So 90% equates to 9 to 1. If we went the other way with this information, prey outnumber predators 10 to 1, to bring it back to a percentage, this, remember, means, in our kind of going backwards version, 10 over 1, if we need the fractions in there. What's the denominator in these fractions? If it's 10 to 1, 10 are prey, 1 is predator. 10 are prey, 1 is predator. That's a cycle of 11. So it's saying 10 out of 11 are prey, which as a percentage, you can type in the calculator, 10 divided by 11, gives us approximately 91%. Not the same as 90%. How does something slip by a big company like Disney and make it into the film that way? I understand 90, 91 are close percentages, and they are. 10 to 1, 9 to 1, they're close. But you would not see that mistake made anywhere that betting was happening. How does a mistake like that get by in Disney? It's not the only mistake I've seen. I've also seen mistakes in McDonald's commercials. You can look for it if you want to. And if you run across any of them, I would be more than happy to see those examples of odds being used mistakenly, because it happens all the time. People do not have a good grasp on this concept for whatever reason. All right, so to review, this video looked at odds. We went in both directions of starting with just probabilities and then finding the odds. And then we also looked at, here are the odds, what's the probability? One special aspect, remember that anytime you're presenting odds as your answer, number, colon, number. I'll see you soon for another video.